I want to introduce an important performance parameter for engines for aerospace propulsion, the specific impulse. The specific impulse is related to the thrust that an engine produces and how rapidly the fuel is used in order to produce that thrust. The notation that we'll use for specific impulse is a capital I with subscript SP. The specific impulse is defined as the thrust produced by the engine divided by the rate at which the weight of the fuel is consumed in order to produce that thrust. Now, if we call the rate at which the mass of the fuel is consumed the mass flow rate of the fuel, then this will be dmp dt, where mp is the mass of the fuel and t is time. The weight of an object is just the mass multiplied by the acceleration due to gravity. So weight is equal to mg. If we multiply the mass flow rate of fuel by the acceleration due to gravity g, we'll get the rate at which the weight of the fuel is being consumed. So if we call the thrust T, the specific impulse is T over g times dmp dt. The specific impulse is an especially good performance measure for engines that might be used to launch vehicles into space, such as rockets and scramjets. For a launch vehicle, we'd like to produce as much thrust as possible out of the fuel that we're carrying. So, to get a high specific impulse, we could generate a high thrust using a low weight flow rate of fuel. The higher the specific impulse, the better use we can make out of the fuel to change our velocity. There's a caveat to that. Some types of propulsive systems can give very high specific impulse, but a low absolute value of thrust. Maybe not enough thrust to overcome the weight or the drag of our vehicle. So sometimes we'll choose to use an engine with a lower specific impulse, but that gives a high value of thrust. Let's look at the specific impulse for a rocket. Let's say that the rocket is expelling its propellant through its nozzle at speed Vp relative to the rocket, at a mass flow rate of dmp dt. And let's say that this results in a propulsive thrust T on the rocket. As we've seen, when we eject mass from a vehicle, the thrust produced is the product of Vp and dmp dt. Now, noting that the specific impulse is thrust divided by the weight flow rate of fuel, we put this expression in for thrust into the equation for specific impulse, and we get the mass flow rate of fuel, dmp dt, occurring on both the top and bottom of the equation. So we can cancel them out. And we end up with the specific impulse for a rocket just being the speed with which we eject the propellant divided by the acceleration due to gravity. So the specific impulse is Vp over g. Therefore, a good performing rocket will have as high a value of Vp as possible. The best performing chemical rockets burn hydrogen in pure oxygen. An example is the Space Shuttle main engine shown here. We usually start with liquid hydrogen, LH2, and liquid oxygen, LOX. This was the combination used in the Space Shuttle's main engines. With this combination, it's possible to eject the combustion products into a vacuum at nearly 4,500 metres per second, giving a specific impulse of around 450 seconds. Yes, I did say seconds. The specific impulse has the rather odd units of time. In the atmosphere at sea level, this specific impulse might drop to around 370 seconds. Solid rocket engines are much simpler than liquid rocket engines, and the speed with which the combustion products are ejected through the rocket nozzle is lower. A typical value might be around 2,600 metres per second. Therefore, solid rockets have specific impulses lower than the best liquid-fueled rockets. For that sort of Vp, the specific impulse would be around 260 seconds. The two boosters attached to the main tank of the space shuttle were solid rockets. This photo shows a launch of the Space Shuttle, and most of the exhaust you can see is coming from the two solid rocket motors. As I noted earlier, there are some trade-offs between specific impulse and other performance characteristics of rockets, such as the absolute thrust produced. The choice of solid rockets as boosters for the shuttle is an example. Despite their lower specific impulse compared with the main engines, the shuttle's solid rocket motors were simple, reliable, and produced the high levels of thrust required for liftoff in a vertical launch. We'll look at the specific impulse of air-breathing engines, such as jet engines and scramjets, in the last subsection of the introduction.